And you are still watching equation of parabola in standard form whose vertex is located at coordinate hk. Part 2.
Uno, dos, tres, cuatro.
The third case of the equation of the parabola in standard form whose vertex is located at hk. If the axis is parallel to y-axis and the parabola opens upward, the equation is the square of the quantity x minus h is equal to 4p times the quantity of y minus k. Suppose that this is our vertex hk and this is our focus, and take note that the distance from the vertex going to the focus is equal to p units. Since that is now a p units above the vertex, then the focus is located at the coordinate h and k plus p. And the directrix, since now the directrix is below the vertex with p units, then we can say that the equation of the directrix is equal to y is equal to k minus p. And the axis of symmetry is equal to x is equal to h. And the length of the latus rectum is 4 times the value of the p. And the coordinates of the endpoints of the latus rectum is coordinates h plus minus 2p and k plus p. And this is now the graph of the standard equation of the parabola. The square of the quantity x minus h is equal to 4p times the quantity of y minus k. Let us have an example. Find the equation of the parabola with vertex at coordinate 1 and negative 2, axis of symmetry parallel to y-axis and passing through the coordinate negative 1 and 2. Sketch the graph. Since the axis of symmetry is parallel to y-axis and the point on the parabola, point P, which is coordinate x and y, is given, which is coordinate negative 1 and 2, is above the vertex coordinate 1 and negative 2. Then we can say that the opening of the parabola opens upward at vertex hk. We are going to use now the standard equation of the parabola. The square of the quantity x minus h is equal to 4p times the quantity of y minus k. Find the value of the p by substituting the values of the vertex hk, which is coordinate 1 and negative 2, and the given point on the parabola coordinate x and y, which is coordinate negative 1 and 2. So we are going to use now the standard equation of the parabola as mentioned above. We are going to substitute the value of the x, which is equal to negative 1, the value of the h, which is equal to 1, the value of the y, which is 2, and the value of the k, which is negative 2. As we are going to simplify further, negative 1 minus 1 is equal to negative 2, and 2 minus negative 2, that is equal to 4. Then simplifying further, we have 4 is equal to 16p. Divide both sides by 16 to isolate the variable p. Then p is equal to 4 over 16. Then simplify 4 over 16 into simplest form, that is equal to 1/4. Then we can say that the value of the p is equal to 1/4. To find the equation of the parabola in the problem, substitute the derived value of the p, which is equal to 1/4, and the values of the h, which is equal to 1, the k, which is equal to negative 2, of the vertex coordinate hk, which is coordinate 1 and negative 2, in the standard equation of the parabola whose vertex is located at coordinate hk and opens upward. As we are going to substitute the value of the h, which is equal to 1, the value of the p, which is equal to 1/4, and the value of the k, which is equal to negative 2, then we can say that the equation of the parabola now The square of the quantity x minus 1 is equal to y plus 2. As we are going to sketch now the parabola, the equation of the parabola is the square of the quantity x minus 1 is equal to the quantity of y plus 2 with the value of the p which is equal to 1/4. As what you can see, the derived equation of the parabola in the problem is in the form of the square of the quantity x minus h is equal to 4p times the quantity of y minus k. These are the coordinates and the equation in sketching the parabola when it is opens upward and vertex is located at hk. The vertex is given, which is coordinate 1 and -2. So as we are going to plot now the vertex, this is now the location of the vertex in the graph. Then the focus is substituting the value for the h, the k, and the p. Then the focus is coordinate 1 and -2 plus 1/4. So as we are going to simplify -2 plus 1/4, that is equal to -7/4. Then we can say that the focus is located at coordinate 1 and -7/4. Then as we are going to plot now the focus in the Cartesian coordinate plane, this is now the location of the focus. The equation of the directrix is y is equal to k minus p. Our k is -2 and our p is 1/4. Then the equation is y is equal to -2 minus 1/4. Simplifying further, we have now y is equal to -9/4. As we are going to plot now -9/4, -9/4, if we're going to convert this into decimal, -9/4 is equal to 2.25. So we can say that this is now our directrix, a horizontal line parallel to x that passed through the y-axis at 2.25, which is y is equal to -9/4. And the value for the axis of symmetry is x is equal to 1. It means that this is a vertical line that passed through the x-axis at point 1. And the length of the latus rectum is 4 times the value of the p. P is equal to 1/4. Then we have now 4 times 1/4, that is equal to 1. Then the length of the latus rectum is 1 unit. Let us find the coordinates of the endpoints of the latus rectum using this coordinate. So as we are going to substitute the value for the h, k, and the p in this coordinate, then we have now the coordinate 1 plus minus 2 times 1/4 and -2 plus 1/4. If you are going to simplify now 2 times 1/4, that is equal to 1/2, and -2 plus 1/4, that is equal to -7/4. So we have now the coordinates of the latus rectum is coordinate 1 plus minus 1/2 and -7/4. So as what you can see, we have now 1 plus minus 1/2. It means that we can now add and subtract 1/2 to 1. So as we are going to split this into two coordinate, so we have now coordinate 1 plus 1/2 and -7/4, and coordinate 1 minus 1/2 and -7/4. So simplifying 1 plus 1/2, that is equal to 3/4, and 1 minus 1/2, that is equal to 1/2. Then the coordinates are coordinate 3/2 and -7/4, and coordinate 1/2 and -7/4. This is now the graph of the endpoints of the latus rectum. This is the graph of the equation of the parabola in the problem. Squared of the quantity x minus 1 is equal to y plus 2. The fourth case of the standard equation of the parabola whose vertex is located at hk. If the axis is parallel to y-axis and the parabola opens downward, then the equation is the square of the quantity x minus h is equal to -4p times the quantity y minus k. Suppose that this is our vertex hk and this is our focus. which is p units below the vertex, then the focus is coordinate h and k minus p. And this is our directrix, which is p units above the vertex. So the equation of the directrix is y is equal to k plus p. And the axis of symmetry is x is equal to h. And the length of the latus rectum is 4 times the value of the p. And the coordinates of the endpoints of the latus rectum is coordinate h plus minus 2p and k minus p. And this is now the graph of the equation. Squared of x minus h is equal to negative 4p times the quantity y minus k. Example number 4. Find the equation of the parabola with directrix y is equal to 1 and focus at the coordinate 1 and negative 3. Sketch the graph. This is now our directrix y is equal to 1. And this is the plot of our focus, which is coordinate 1 and negative 3. Since the directrix, a horizontal line that passed through the y-axis at 1, and the focus at coordinate 1 and negative 3 is below the directrix, then we can say that the parabola opens downward whose vertex located at hk. As what you can see, by inspection, the distance from the directrix going to the focus is 4 units. And take note that the distance from the focus going to the directrix is twice the value of the p. So we are going to solve for the value of the p by equating 2p, which is equal to 4. Then divide both sides by 2. Then the value of the p is equal to 2. And we have to look for the vertex hk. Since the focus is coordinate 1 and negative 3, and it is coordinate h and k minus p, when the parabola opens downward and the vertex located at hk, and the value of the p is equal to 2. So we have to look for the value of the k. We are going to equate now, since k minus p is equal to negative 3. So let us equate k minus p is equal to negative 3 and substitute the value of the p, which is equal to 2, in order for us to find the value of the k. Since we already have value for h, which is 1, we have to look for the value of the k. So substitute the value of the p, which is 2. We have now k minus 2 is equal to negative 3. Then we have to transpose negative 2 on the other side of the equation. So we have k is equal to negative 3 plus 2. And k is equal to negative 1. Therefore, the vertex is located at hk, which is coordinate 1 and negative 1. As we are going to plot now the vertex, this is now the location of the vertex, coordinate 1 and negative 1. Since the parabola opens downward and the vertex located at hk, we are going to use now the standard equation of the parabola. Square of the quantity x minus h is equal to negative 4p times the quantity y minus k. To find the equation of the parabola, substitute the vertex h and k, which is coordinate 1 and negative 1, and the value of the p into the above equation, as we are going to substitute the value of our h, which is equal to 1, and the value of our p, which is equal to 2, and the value of our k, which is equal to negative 1. So we have now the square of the quantity x minus 1 is equal to negative 4 times 2 times the quantity of y minus negative 1. As we are going to simplify negative 4 times 2, that is equal to negative 8. Then y minus negative 1, that is y plus 1. So we have now the square of the quantity x minus 1 is equal to negative 8 times the quantity y plus 1. So this is now the equation of the parabola in the said problem. So let us now sketch the parabola. We already derived now the equation of the parabola in the problem, which is the square of the quantity x minus 1 equals negative 8 times the quantity of y plus 1, which is, it is in this form, square of the quantity x minus h equals negative 4p times the quantity y minus k. If this is the standard equation of the parabola, these are the coordinates and the equation of the parts of the parabola. Then given the focus, which is coordinate 1 and negative 3, and the directrix, which is y is equal to 1. Then we already derived now the vertex, which is at coordinate 1 and negative 1. In finding the axis of symmetry, that is x is equal to h, where h is equal to 1, then we can say that the axis of symmetry is x is equal to 1. It means that it is a vertical line that passes through the x at 1. And the length of the latus rectum is 4 times the value of the p, which is p is equal to 2. Then the length of the latus rectum is 8. And what are the coordinates of the endpoints of the latus rectum? Using this coordinate h plus minus 2p and k minus p, substituting the value of the h, the k, and the p, then we have now coordinate 1 plus minus 2 times 2 and negative 1 minus 2. So 2 times 2 is equal to 4. Then negative 1 minus 2, that is equal to negative 3. So simplifying further, we have now coordinate 1 plus minus 4 and negative 3. If we are going to split now this into two coordinates, take note that 1 plus 4 is equal to 5 and 1 minus negative 4 is equal to negative 3. Then the coordinates of the endpoints of the latus rectum are coordinate negative 3 and negative 3 and coordinate 5 and negative 3. So as we are going to plot now the endpoints of the latus rectum, this is now the graph of the latus rectum with its endpoints of coordinates. And as what you can see, the distance of the endpoints of the latus rectum measures 8 units. Then we can say that this is now the graph of the equation of the parabola squared of the quantity x minus 1 is equal to negative 8 times the quantity y plus 1.
And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.